All right, hello everybody. Welcome to video 5. This is the third part in the URL shortener slash Base62Encoder, which we're going to use to explore functional programming in different languages. So what I have here on the right side is the Java program that I talked about last week. We walked through it. This is a Base62Encoder. It's basically going to do what you see in Bitly or TinyURL. It's going to convert a long string into a hash code and then convert that hash code into a small string using Base62 encoding. And again, watch the videos, the first couple of videos, which I will link in the show notes, please, for more background information on that. Now, I have on this side a non-functional version of Scala, which is a transliteration of the Java version, a straight up transliteration, line by line, as you will see. And then I have the Java version, which runs pretty much the same way. So you can see they give the same answers. And then I have a functional Scala version, which tries to use some both idiomatic Scala, more idiomatic Scala, and it also tries to do functional programming. So to a greater or lesser extent. Let's cover this quickly. So we got video 5 show notes. I'll link this in the video. This is the porting the Base62Encoder decoder from Java to functional Scala. Step 1 is we're going to move. Going back and forth in the IDE might be confusing, so I went ahead and put that all on the show notes page. I created little tables, so you have got the Java on the left and Scala on the right, and you can see pretty much this is the same. So we're taking this long URL, we're getting a hash code, and we're converting that hash code into a small string, just like TinyURL or Bitly does. See the first 2 articles if you don't know what I'm talking about a URL shortening. It's a very simple application. Now, because this is a transliteration, you'll notice the Java version, the Scala version are pretty much line by line the same. There's some differences, some syntactical differences. In Scala, functions and statements like if, for, whatever, they have values. So this function has the value of a string, so we use the equal operator to say it's equal to this body. And another thing that does is we don't have to use the return statement because the last item in this body will be the value of the function. So it'll be builder.toString. Otherwise, these look very, very similar. Again, slight syntactic differences. In Java, we have to do a cast to an int. In Scala, we do a toInt operation. Here we have a find bucket that's identical, right? I mean, it's just, this is a Scala syntax, like things I noted earlier, but otherwise identical. Same with the PAL digits base. Now the IDE will do most of this for you. You just cut and paste the Java in and it converts it to Scala. You'll may have to change maybe things slightly. Of course, this is not the way that you necessarily want to write Scala. We're gonna have another example we're going to cover here shortly that does that. So here's the append safe. The only real difference here is I use extra brackets, but I could have done that. That was more of a stylistic choice. So don't think that Scala is necessarily shorter in this instance, although it is in others for sure. And we'll see that more when we convert functional Java to functional Scala. There are some features in Scala that make it better for functional programming, but with Java 17, Java 19, that's becoming less and less. Although it hasn't gone to 0. Yet. Now in Scala we have this var accumulator, right? It knows that it's an int a long because you assigned it to a long. Here we specify a long, we don't use final. So not using final is the same as using var. Conversely, once we use final, here's an example of using a final, that's the same as using val in Scala. So final int val, and here we use val, and it figures out the type by looking at the type of the function of the find index of digit in table, which is an int, and this is a long, so multipliers are long, and they work the same otherwise. So very similar at this point. And that was the point. I wanted to do a transliteration and then convert into functional Scala. So here's the functional And this should really say functional / idiomatic Scala, not just functional. So we try to be more idiomatic as well. You'll see that this version is a little shorter. So here we have the main method, nearly identical. I'm still using printf on this side. On this side, I start using println with the string substitution that Scala has for templating, which is real nice, built into the language. And then we have the convert to encoded string. This is the non-functional version, which was a direct port from the non-functional Java version. This is the functional Scala version, and it has a recursive method. So this method calls itself, and this is the sort of the exit, and that'd be equivalent to this in the while loop. Now, it's arguable which one is easier to read. I would say most developers could probably read the while loop a little easier, but you know, we do have this option. Scala has these tuples, which make things like creating accumulate digits easier, because if you need to return a bunch of things when you're accumulating something or doing a calculation with a tuple, you can do that without declaring a class. Java 17 and 19 get a little better at that, but we can see how that evolves when we compare, you know, the functional Java kind of circa 11 versus the Java 17, that this gets a little better, but we'll get there when we get there. There's a less of a difference, I think, going forward between Java and Scala, but it's still there, and we can discuss that and debate it, or if you want to debate it, it doesn't really matter. This could have been simplified down to one line of code in Scala. We could have gotten rid of the brackets. We could have gotten rid of this intermediate variable and just called or else. But I wanted to make it a little more readable, and I think this version I'm fine with, and it's not much different in size from the non-functional version. Here we have the PAL digits base. This again is a recursive function. Now later on, when we convert this into Clojure, which if you listen to the first video, that was kind of one of the ideas behind moving it to Scala, moving it to something more functional so that I could convert it to Clojure a little easier, because I wanted to learn Clojure for another project, and then I was like, I could compare this to other languages too, and then just kept going and compared it to JavaScript and TypeScript and Python and Rust and so on and so forth, and different versions of Java. So here we have our convert to long. This version is using a higher order function. A higher order function, and you will see when we cover the Java version of this that their support for higher order functions isn't quite as good as Scala, not even close. So, but yeah, this is a higher order function. We're using a lot of features of Scala here. We're using pattern matching. We're using lambdas, closures. And we're using, what else are we using? Quite a bit, and higher order functions. So this is a pretty good example of what a functional version versus a non-functional version will look like. This is a for loop. This is a fold left, and it'll be nice when we are comparing this to other languages as well. Some support this really well, and some do not. Scala does this very well, by the way. Here we have compute value. And compute value is the same. I didn't do anything with that. I'm not even sure why I added that to this table. So then we have find. We could have done this with Java, index of. I was thinking of a way to do it with a higher order function, and like, oh, index of, but I could have done that with Java. It's not necessarily higher order because we're not passing it a function. Functions are first-class objects in Scala. So that's the basic of converting it into Scala, then from converting it into Scala into something that's more functional, programming friendly, which we will then use as our base when we start converting this into Rust and Clojure and Kotlin and back into Java functional programming, et cetera, et cetera. So it's a nice way to compare these languages with somewhat easy but non-trivial example. And yeah, I hope you like this. Tune in for the next one. In the next one, we're going to cover writing the functional Java version, and then moving the functional Java version to Java 17/19 and how that simplifies things. So we'll be able to compare functional Scala to functional Java, talk about some of the caveats and gotchas with the functional Java and why things are a little bit easier in Scala at this point in time. And then, actually, no, next week we're covering Clojure, or next video. I say a week, but it's not necessarily going to be a week. The next video we're going to cover Clojure and compare Clojure to the functional Scala. And then after that, we're going to compare functional Scala to functional Java and talk about some of those caveats, and then look at Java 17 and how it gets rid of some of those and reduces the gap but doesn't eliminate it per se. I still think Scala is a much better choice if you're doing or embracing functional programming at this point in time. Tune in. Thanks for tuning into this. Tune into the next one. See you next time. This is Rick Hightower talking about random stuff to deal with software engineering. We're going to do a lot of these. Got a lot of ideas, so hope you like it.